So as a follow-up to the last video, I'll talk about hypercubes, which are a special kind of Cartesian products, or rather they can be defined with Cartesian products of graphs. So the hypercube Qn in general, so this is a family of graphs. This is defined to be Qn is K2 if n equals 1. So that is Q1 is the same thing as K2. And then for anything bigger than that, Qn is Qn minus 1 Cartesian product with K2 for n greater than or equal to 2. So this family of graphs can be defined recursively in terms of Cartesian products of graphs. So let's just take a look at a few of these and see how this family looks. So I'll draw Q1 here is K2. So there's K2. Q2 is K2. So Q1 this will be the same as Q1 box K2. So that's K2 cross K2. So this is the same. Yeah, I'll say K2 box K2. So, right, so I have K2 and K2 for every vertex of the second graph, or I'm going to copy the second graph for every vertex of this graph and join them up. So here's copy 1 of K2, copy 2 of K2, and then they're joined up according to the adjacencies here. So that means this vertex would be adjacent to its copy, this vertex would be adjacent to its copy. And so we get here, we get C4. This is the same thing as C4, 4 cycle. We can keep going. Q3 will be Q2 box K2. So I'll take Q2 and copy it twice, once for each vertex of K2. And yeah, I'll copy it twice. And then I'll join up each vertex with its copy. So that means this vertex will go here, this vertex will go here, these two vertices would be adjacent, and these two vertices would be adjacent. So here's one way to picture Q3, but there's another drawing of this that looks a lot nicer. So I'll say it's isomorphic to. One thing I can do is I can put the two copies sort of inside each other so that the copies are right next to each other. There's my outside copy. And here's my inside copy, and I've joined up each vertex with its copy. And so here's another variation of Q3. I'll let you keep going with that. You should be able to draw Q4 past this. The book also gives another definition of how we can define the hypercubes using n-bit strings. I think that's also pretty interesting. There's a couple ways to define this family of graphs. But I like this idea of using Cartesian products to do it.